Hello everyone, my name is Chris Robin and this is my web development project. I chose the Know Your Cyber client brief which asked me to build a website for a charitable organization that helps the public understand cyber threats. So let me walk you through my website first. When you first land out on the website, you can see the homepage. The site has a dark black background with red accents everywhere, which suits the serious nature of cybersecurity. At the very top is a sticky navigation bar with the Know Your Cyber logo on the left and 5 navigation links on the right. We have Home, Threats, Check Yourself, Stay Protected, and About. You can also see a parallax background effect on the hero section, the hooded figure image, and as you scroll, giving the site a more professional feel. Below the navigation link is a large header banner with the site title and a short description and 2 buttons, one linking to the threats database and one linking to the check your details page. Scrolling down, you can see a section explaining what Know Your Cyber is, followed by a statistics section showing 4 key facts about cybercrime displayed in dark boxes. Below that are 3 cybersecurity images displayed side by side, and then a section explaining why cyber threats matter. At the bottom of the page and every page is a footer showing the copyright year which automatically updates every use of JavaScript. Now, we'll move on to the threats database. Here we go. This is the threats database page, which is the most important page on the site and directly addresses the additional requirement of loading data from a database using JavaScript. When this page loads, 12 cyber threat cards appear on the screen automatically. These cards are not hard-coded in the HTML. They are loaded dynamically from a JSON file using the JavaScript fetch function, which I show in the code walkthrough shortly. Now, each card shows the threat name at the top in white, a colored severity badge, dark red for critical, here we go, orange for high, and then yellow for medium, and then green for lower screen. Here's green. And then the category, year recorded, and then who is affected and prevention. At the top of the page, there are 2 controls. The first is a search bar where you can type a threat name. If I type phishing, for example, phishing, there we go, phishing. Only the phishing related threat appears instantly without even the page reloading or even the other cards. Now, over here, the second control is a category dropdown. If I select malware from the dropdown, no wait, here we go. If I select malware from the drop-down, only malware threats are shown, so both filters also work together at the same time. Now, moving on to the Check Yourself page. This is the Check Yourself page. It has 2 interactive tools built entirely with JavaScript. This is the first tool, Email Checker. If I type in one of the emails from our breach database, like any email, and click Check Email here, a red warning message appears here telling me this email has been found in a known breach or it's not. If I type an email that is not in the database, a green safe message appears instead over here. The second tool is the password strength checker. If I type a very common password like 123456 or QWERTY password and click check password, it tells me the password is dangerous. But if I type a really strong password in uppercase letters, lowercase letters, numbers, and symbols, it gives me a green message confirming it is strong. Example here, I'll type 123456, 123456. I'll show right here. See? If I type like maybe a medium, something like that, it will still show like this, moderate password. But if I do a long password, that is a mix of uppercase letters, numbers, or signs, there we go, it will now show this one. So it's really how this works on the password checker. Now, over to the Stay Protected page is here. It starts with a short introduction followed by eight practical cybersecurity tip cards covering topics as such as strong passwords, two-factor authentication, avoiding public Wi-Fi here, and backing up data. Below the Below the tips is an embedded YouTube video about cybersecurity for beginners, which provides additional rich media content. You can search this on YouTube right here. And below the video is an interactive security checklist with items that I put on. When you tick a checkbox like this, the text strikes true and turns gray. That shows that step is already completed if you've done it on your end. This checklist is built dynamically using JavaScript. It is not hard-coded in HTML. Now, onto the About page, which is the final page of my website. It tells the visitor who Know Your Cyber is and what they do, displayed across three cards covering education, awareness, and prevention. Below, that is a section on the organization values, a statistics row, a contact section box. Now, onto the coding setup. Here's my threads.html. The most important part is this JavaScript section at the bottom. This is the fetch function. Right here. It sends a request to load the threads.json file from our data folder. When the file loads successfully, the .json method converts the response into a JavaScript object, and the data is passed into the display threads function over here. If the file fails to load for any reason, a catch block handles the error and shows a message to the user instead of breaking the page. The display threads function takes the array of threads and uses the map method to build an HTML card for each one. Using a template literal, it then injects all the cards into the page at once using inner HTML on the trainer container div. This means all 12 cards in the website are generated entirely by JavaScript from this data. Nothing is hard-coded in HTML. The filter threads function right here runs every time the user types in the search box or changes the dropdown. It uses this JavaScript filter method to check which threads match both search text and the selected category, then calls displays or threads again with only the matching results. This is how real-time search and filter system works right here. Now, over here is the threads.json file inside the data folder. This is the mock database that powers the threads page. Each thread has eight fields: ID, name, category, severity, description, affected, year, and prevention. Having the data stored separately from the HTML makes the site much easier to maintain. New threads can also be added just by editing this file without touching any HTML code at all. Now, here's the CSS style sheet, which is shared across all 5 pages using a single link tag in each HTML file. This might be a long code, but I'll just explain it why. I've used CSS variables at the top to control all the colors from one place, which makes it easy to change the color scheme if needed. The dark color scheme uses black background with red accents to match the tone of the object. The card grid uses CSS grid with autofill columns, which means the number of cards per row adjusts automatically based on the available screen width. I use some CSS transitions on the cards and navigation links to create some smooth hover effects. Then the page header uses a background attachment fix property, which creates the parallax scrolling effect you saw on the website on the image. The severity badges also have their own color classes. The badge critical, the dark red one, the badge for high, I think it's orange, and then badge for medium is yellow, and then badge for low is green. Now, over here is my main.js file, the global JavaScript file that is linked to every page. It does three things. First, it highlights the active navigation link by comparing the current page file name to each link's href attribute. Second, it scrolls to the page to the top on load. Third, it automatically replaces the hard-coded year in the footer here, right here, with the current year using the JavaScript date object, which is why the footer shows 2026 instead of hard-coded 2024. Now, finally, here's my index.html, the home page. You can see the semantic HTML elements used throughout. Nav for the navigation link by comparing the current, wait, oh yes, nav for the navigation bar, header for the hero section, main for the page content, section for each content block, and the footer for the bottom of the page. All 5 HTML files follow the same uh, consistent structure on the website. Every file also includes a comment at the top, also acknowledging that I've used AI, was used as a development tool so that it can help me in this assessment, as required by the assignment guidelines to reference any AI. So I think that is all. Thank you for watching. Goodbye.